All right, everybody, big finish on Unit 4. Today's the day. We are officially putting together all of our extremely useful knowledge of the unit circle and all these identities. Got to be willing to just take a guess and try something, and if that doesn't work, try something else. The left side of this verification problem, number 1, is probably the most obvious to use. We are going to use the sum and difference identity. This is not distributive property. Okay, so cosine on your sum and difference identity paper. If you look at it, it goes, if you try to write, it goes cosine, cosine, sine, sine. And then the angles go first angle, second angle, first angle, second angle. And then, of course, we want the other sign. If we're adding, we're going to be subtracting in the solution. So then we're just going to go ahead and figure out this information. We don't know the cosine of x. Of course, that's not an angle. Cosine of pi over 2, that's 0. Don't know the sine of x, but the sine of pi over 2 is 1. Anything times 0 is 0, and we're down to the negative sine of x, which is the goal. This is a good one with a lot of different identities. Same thing with number 4. Start using the trig identities. That's the whole point. If you're not using the trig identities, that could be your mistake. So the sine of 2x has only one choice, which is 2 sine x cosine x. Oops. Sorry. And then I'm going to put that over 1 because I really want to make my tangent sine of x over cosine of x. And then we can do like this. So now we have 2 sine squared x cosine squared x. That sine's not squared. Sorry, I don't know where I got that from. That's a lie. All right, so then we have 2 sine x cosine squared x over sine x. These are going to cancel, and we're left with 2 cosine squared x. Even powers are difference of 2 squares. If there's a minus sign, we have the even powers here. So this is going to be the difference of 2 squares, which we kind of like because of that plus. Cosine squared theta minus sine squared theta times cosine squared theta plus sine squared theta. Well, we know that's a 1. Are you looking at the trig identities? Because cosine squared theta minus sine squared theta of course, that's times 1, but that's not going to matter. Look at them. Look at the trig identities. Look at your answer. We're finished. Number 4, trig identities everywhere. No choice for the top. 2 sine x cosine x. The bottom. We've got a lot of choices for the cosine. The double angle, rather. So look at what we need. It would be nice if, I don't know, we're trying to end up with tangent. So if we think backwards from tangent a little bit, this is sine over cosine, which is conflicting because I have the sine squared in there. I'm going to go with the one that's sine squared in hopes that I can do some addition, maybe simplify this. I might be wrong, and then we'll try something else. But I'm going to try the sine squared one first. 1 minus 2 sine squared plus sine squared. The numerator is good. I don't think we can do anything with that. But the denominator, we've got some terms we can combine right here. So this is going to be 1 minus sine squared. Oh, look at that. That's Pythagorean identity. 1 minus sine squared is the cosine squared. And we know we want to do that because tangent should have cosine in the bottom. So that's a good sign. And then we're going to get rid of that. So then there's a cosine in the bottom. We're left with 2 times the sine over the cosine. Even if the 2, if you think of the 2 on the top, which is where it is, the 2 is just still there. It's still 2 over 1, which is 2 tangent x. We're there. Smooth like butter. All right, solving in degrees. On the test, and let's talk about that, you're going to have your calculator. So you're going to have your calculator for the whole thing. You're going to have your calculator for the whole thing. Hello. Which means use your calculator. You don't know the unit circle? You can use the calculator. Degrees makes it nice. Cosine of 2 theta. I'm going to go with the sine squared one again just because of the word sine. I know it's not going to cancel, but at least I got it into one word. So remember, the goal is to try to get this thing into one word first. So 2 sine squared theta minus the sine of theta equals 0. Combine these. 1 minus... No, we can't combine those. What am I doing? Don't do that. Don't do that either. All right, so this is going to be rearrange. Negative 2 sine squared theta. Sorry, I was still verifying. Minus the sine of theta. I'm just putting this in some kind of order. Plus 1 equals 0. I don't like to factor with a negative sign in front, so I'm going to change all the signs. So sign the plus or minus signs. So positive, this is going to change to a positive. And then, of course, that's going to be a minus 1. Now I can factor it a little easier. The only way to get 2 sine squared is 2 sine times sine. The only way to get 1 is 1 times 1. Of course, I want this outer one to be the positive so that I end up with a positive 1 in the middle. Set each factor equal to 0. We get sine is 1/2, and the sine of theta is negative 1. Sine is positive, of course, in 2 quadrants. First quadrant, second quadrant, so 3150. Sine is negative 1 straight down, 270. Cosine of 2 theta, lots of choices. I'm going to go with the cosine squared one because the other side. So I have 2 cosine squared theta minus 1. Just copied right down from the formula sheet, your identity paper. You don't have to know those, you just have to have them handy. I'm going to subtract cosine squared to try to get everything together. And it does simplify. So we have cosine squared theta minus 1 equals 0. Move the 1 to the other side, take the square root. So the cosine is equal to positive and negative 1. That is in degrees 0 and 180. Pause this at any time and just write these down. I know that I'm talking as fast as I'm writing, but you can also pause this and take a look at it. So you might need to do that. Now we're in radians. It doesn't really change anything. Sorry, it's so crooked and like distorted or something. It's weird. Distracted. Now for this, sine squared and the word cosine. You can't do anything with the cosine, right? That's pretty much you're stuck with it. Sine squared, we've got some options. Look at your Pythagorean identities. Sine squared is really 1 minus cosine squared. I don't really know if that's going to work, but I'm going for it. And you can distribute the 4. So we have 4 minus 4 cosine squared plus 4 cosine x minus 1. I'm going to rearrange this. Negative 4 cosine squared x plus 4 cosine x, and then 4 minus 1 is a 3. And I'm going to change all the signs because I don't like to factor with a negative sign first. So all of these are going to become the opposite. 4 cosine squared, I got some choices. Yikes. I'm going to go with 2 cosine squared and the 2 cosine squared. I feel like 3 and 4 are pretty close together, so if I go with the 4 times 1, it might be too far apart. So I'm just going to try this. I'm going to put the 3 out here and the 1 in here just as a guess. Outside is 6, inside is 2. Nice. 6 minus 2 is 4, and so that'll work. So I want the 6 to be negative and the 4 to be positive. Here we get 2 cosine squared x plus 1 equals 0. 2 cosine squared x equals Why do I have cosine squared? Why don't you tell me that was wrong? It's just cosine. I'm thinking it's to the 4th power because of all the 4s. Sorry. So then this is going to be -1. Oh, hi. And then cosine is equal to -1/2. And that is here and here. It's pi over 3. So it's 2 pi over 3. And 4 pi over 3. I almost had to stop thinking here. So then this one is going to be 2 cosine of x equals 3. The cosine of x equals 3 over 2. Too big. All right, cosine has to live between -1 and 1, so this side doesn't work, but this side does. So we have some answers. That was a little rougher than I thought it would be. Number 8, we have one identity for this, so let's fill it in there. 2 sine theta cosine theta minus sine theta. Look at that. They have a sign in common. We're going to factor that out. So we have 2 cosine theta minus 1. When you have two different words like that, because I know we had sine and cosine there, look for greatest common factor. It's usually going to be there. So now we have that the sine of theta equals 0, and 2 cosine of theta minus 1 equals 0. So here we get the cosine of theta, add the 1, divide by 2. So where does the sine equal 0 in radians, 0 in pi, and 1/2? Oh, we just did the -1/2, so the positive 1/2 will be pi over 3, and 4th quadrant, 5 pi over 3. This, what you're looking at here, pretty much is the test. You throw in some other problems with some numbers, but this is probably 80% of the test, what we're doing here. So take your time, try your assignment. If you get frustrated, stop, and we'll get your questions answered in class.